Hi, my name is Gabe Hollombe, and I'm a Senior Developer Advocate here at Amazon Web Services. Thanks for joining us. In this session, Realizing the Business Value of Modernizing, I'll provide an introduction to the different areas of value customers have seen after using AWS to modernize their technology stack. And while cost savings are the primary motivation for organizations to move to AWS, I'll also review how other areas of benefits have a far greater impact. Our cloud economics team works on hundreds of customer business cases across the globe each year. When we speak to customers about the value they've realized from using AWS, we hear 4 common areas of benefits. Using those 4 areas, we developed the AWS Cloud Framework. The first pillar of our Cloud Value Framework is cost savings, which is realized by avoiding large fixed costs for on-premises infrastructure and reducing the variable cost through AWS's economy of scale. When working with our customer Live Nation, the world's leading live entertainment company who produces live concerts, sells event tickets, and connects sponsorships, we saw some great savings. Live Nation had a very short timeline to migrate 668 servers onto AWS. When building the business case, we estimated the team could save 18% of their costs. And in fact, right after their full migration, they realized close to 20% savings in total cost of ownership. And as they gained more experience operating in the cloud, they were able to realize a 40% reduction within 12 months and a 58% reduction in 18 months. Now, when you think about the basic economics of the cloud, let's look at infrastructure costs on the y-axis and time on the x-axis. When you're looking to forecast demand of IT resources for your business based on the projection of business growth, you'll probably create a simple straight line demand curve. To meet this demand, large fixed infrastructure spend is added in a step function basis. So capacity is added in a way that follows this dotted line. Now, in reality, actual demand is volatile, and it'll look something like this curvy line. Depending on the seasonality in your business and operations, you'll see peaks and troughs of capacity consumption. Essentially, everything below that zigzag line and above the curvy line is anything below your actual capacity and above your actual demand. That's the opportunity cost incurred due to over-provisioning. And that's also where some cost savings comes from. The other thing to note is that typically customers will provision anywhere between 20 to 50% over their peak predicted demand. A recent McKinsey study found that over 30% of servers were utilized less than 10% of the time. And those industry averages are exactly why there's so much value to be realized from migrating to the cloud. Now, why do some companies provision that far above predicted demand? Well, it's because when the curvy line exceeds the zigzag line, or your actual demand exceeds your capacity, well, that's slow servers. That's unresponsive applications. That's downtime. Possibly that's unsatisfied customers. With AWS, you have the opportunity to operate as close to the demand curve as possible by using best practices, including right-sizing your resources to peak utilization requirements and using elasticity to shut down resources when you don't need them. As mentioned earlier, the attempt to avoid a server malfunction due to an overloaded server, to avoid the likely compromised customer experience or lost revenue, made many organizations over-provision their on-premises infrastructure. To be exact, 84% of the on-premises workloads are over-provisioned. We identify this as the first area for cost saving, as you can now spin up and down resources as you need. Second, in AWS, we offer a variety of pricing models where you can reserve resources in advance for steady workloads and achieve a discount up to 70% with reserved instances. Or you can bid for resources with spot instances with up to a 90% discount for workloads that are fault tolerant. The third main area is that because of our economies of scale and our continuous innovation, AWS continues to lower prices for our services. In fact, as of the date of this recording, we've reduced prices 80 times for our customers, and these price reductions are automatically applied to your bills. When we build a total cost of ownership analysis, it's important to have a total cost of ownership view. This means you need to look at the server, storage, and networking costs, and you have to look to the right. So for example, on server costs, it's not just the raw procurement cost of the server, it's all the hardware that comes with it. It's the server, it's the rack, it's the chassis, it's the PDU, it's the top-of-rack switch, and the maintenance on all that hardware. It's also any software that you may have to install on those servers, operating systems, virtualization licenses, and maintenance on that software. And lastly, there's facilities costs. You have to consider the space you rent, power, and cooling costs. In our experience, customers often struggle with quantifying the rightmost column, the facilities cost. It's because these costs typically are shared across business units and products and lines of business. And so, they can be difficult not only to quantify, but also to allocate properly. Here's a summary based on our team's analysis on over 700,000 physical servers in both Linux and Windows operating environments over a time period of 5 years. It shows the total cost of ownership is about 3.5 times the cost of the hardware. Please note, though, that depending on the operations environment, the ratio varies. 2.7 times the cost of the hardware in Linux environment and 5.5 times the cost of the hardware in a Windows environment. Here, N is our over 700,000 physical servers, which were 400,000 Linux and 350,000 Windows. T is our 5-year view. Facilities is power, cooling, and space. Rack is the physical rack and its one-time setup. Hardware overhead is maintenance and provisioning for spares. The multiplier is 2.7 for Linux and 5.5 for Windows, though note that Gartner uses a 4x multiplier. And as time increases, the multiplier goes up. Here's an example of total cost of ownership analysis where we compare the on-premises cost of a non-virtualized physical server with 16 cores and 64 gigabytes of RAM operating at about 50% utilization to its equivalent in the AWS environment, a C5 4XL EC2 instance. The list price for the on-premises hardware is about $13,000 from industry data, or $8,000 with a 40% discount. Also shown here in the on-premises column are typical related costs in the areas we just discussed. Comparing this to the AWS costs, we have a 3-year reserved instance for this comparable instance type costing $6,500. The business support level from AWS for this would cost $650 because it's 10% of the AWS spend. And your labor costs are typically around 1/4 when compared to a physical server since you're not working with the hardware. Comparing the totals, you're looking at $22,400 for the on-premises approach and only $8,500 for the AWS Cloud option. Now I'm going to quickly go through the insights that we learned from our benchmarking studies for cost savings. These are from over 1,500 customer surveys from companies who've migrated to AWS for more than a year. And here's what we learned. Overall, all customers reported a 19% reduction in IT infrastructure spend on AWS versus on-premises. Again, these are all customers that have many other factors causing total costs to go up or down, like some of them double the size of their business or significantly increase in users. So, when we normalized it by looking at spend per user, the cost per app user dropped at a higher rate than the total infrastructure spend to 27.4%. We then sliced the data to see if these cost reductions continue as customers mature and scale on AWS. What we learned, as you see in the middle chart here, is that for apps with greater than 1,000 users, spend per user dropped 42.4% after migrating to AWS. These first two charts have the same horizontal or x-axis in that they depict relative spend on-premises and on AWS. Now, the last chart here only shows the on AWS portion or after migration portion. But these are cut into two groups, those that are multi-cloud and those that are AWS exclusive. These show that there's a 12.3% lower cost per user for AWS exclusive customers. Again, these are the benchmark average of over 1,500 customers. Any individual company's changes will probably vary. Next, let's move on to cover staff productivity. As a reminder, staff productivity essentially is the benefit of eliminating or reducing the time spent on tasks that are no longer needed with the cloud. Essentially, what happens is that tactical work drops, and that tactical work is able to be replaced with more strategic work. And typically, what we see with customers is that the differential increases As less time is spent on tactical tasks, companies have more time to spend on strategic tasks, as higher-level AWS services and managed services are adopted. Staff productivity is all about making your staff more productive by reducing or eliminating the time spent on tasks that are no longer needed once you move to the cloud. Here, we have employee activity on the y-axis and their organization's maturity with AWS on the x-axis. We've noticed that as organizations get more mature on AWS, tactical work drops as you adopt AWS and reduces even further as you mature in your adoption of the cloud. And teams are enabled to do more strategic, more effective work, which means more closely aligned results to business goals. There are 6 roles that we typically consider in relation to staff productivity: server, network, storage, application, facilities, and security. In our models, each of the 6 roles have about 15 to 30 typical tasks. In this particular example, we're looking at a subset of tasks that a server administrator typically performs. Of course, the specifics of what a server administrator does will vary by organization, but these tasks are typical. Along with the tasks, we indicate the typical reduction in time spent on the task based on what other AWS customers have achieved. Certain tasks, like installing, upgrading, and removing software, are significantly reduced with AWS, whereas other tasks, like arranging for hardware repair in the event of a failure, are completely eliminated with AWS since there's no hardware for you to manage. These tasks take up a certain percentage of a full-time equivalent employee's time. In our server administrator example, these tactical tasks, like server budgeting or hardware repair, take up 25% of his or her time. And on average, by moving to AWS, we see an average reduction of 75% for the time spent on these tasks. Therefore, you can expect to see around an 18.8% efficiency gain per full-time equivalent employee. Now, let's look at the benchmarks for our second pillar, staff productivity. We measured these with virtual machines managed per admin and terabytes managed per admin, both during on-premises workloads and after migrating to AWS. What we found from our benchmarking was that overall, after migrating to AWS, there was a 57.9% increase in VMs managed per admin and a 67.7% increase in terabytes managed per admin. These are the 2 charts on the left of the slide here. We also had a lot of profiling questions in our study, and what was really significant was looking at those customers that re-architected, refactored, or re-platformed to fully leverage the functionalities and benefits of the cloud. Their staff productivity metrics saw more than double the improvement seen in the overall populations. And those customers that just simply lifted and shifted or are still co-hosting on the cloud and on-premises. Let's move on to the next area of our Cloud Value Framework, operational resilience. Operational resilience is the benefit of improved availability and security that comes with AWS. What you see on screen here are figures from industry analysts that speak to the cost of outages and the cost of downtime. In terms of the impact, we have estimated downtime costs to range anywhere from $50,000 for low-impact applications to over $1 million for high-impact applications. These are large numbers. The cost of downtime and security risks to applications are extremely high, and the potential impact to your business is significant. While these events may not be frequent, when they do happen, the cost is very high. And so it's important to at least include this component in your business case. We've seen some customers who are uncomfortable with adding a dollar value to these benefits, and so they leave these in terms of KPI benefits. For example, measuring impact on application availability. And that's a recommended approach if your organization is uncomfortable putting a dollar value here. In that case, the takeaway here is that you should set a list of KPIs and track their progress, because the impact when these events do happen is very real and significant. To share some examples of low impact and high impact applications, a high impact example might be in manufacturing. Say, SAP goes down, resulting in no purchase or billing capabilities and a delay in product manufacturing. A medium impact example could be a failure in an internal troubleshooting system, which might result in customer complaints. This is, of course, important, but perhaps not as urgent. And a low-impact example might be a printing system outage, which would likely have only a small team-level impact. Based on research from the Ponemon Institute, which conducts independent research on data protection, privacy, and data security and technology, informing customers on how to improve upon data protection initiatives and enhance their brand and reputation, there are several key drivers that impact the cost of downtime, and we bucket them into several categories. You can use this as a rough guide to think about the costs of outages of your applications. Next, let's look at an example of how to use this as a guide to quantify the downtime cost. In this example, we'll look at a cost of downtime and what improvements there look like. Let's take a media company who's looking to improve the SLAs of their advertisement deliverable. From the 9 categories of cost drivers on our last slide, we'll start with business user productivity. Let's say there are 1,500 employees in the company with an average annual salary of $125,000. We use the standard 170 work hours per month to get a per minute cost per full-time employee, around $1. Therefore, for this media company, the cost of downtime is $1,500 per minute since we have 1,500 employees. For the rest of the cost, for example, equipment, detection, the after-the-fact disruption, it amounts to about half the cost associated with the disruption of business user productivity, which gives us $750 per minute. So, the downtime cost totals up to $2,250 per minute. The current SLA of this media business's advertisement deliverable is 99.4%. With AWS, they were looking at improving their SLAs by 0.1%, which is 525.6 minutes out of the 525,600 minutes in a year. This will yield an uptime gain of $2,250 per minute times 525.6 minutes, or $1,182,600. Part art, part science. Now, looking back at the benchmarks for operational resilience, here are some of the KPIs we measured. These show that customers have reported a 56.7% decrease in downtime after migrating to AWS. Further, they've reported a 24.1% decrease in total monthly incidents and a 31.8% decrease in critical incidents after migration. So, we have lower downtime, lower incidents, and lastly, it also showed a 39.3% decrease in mean time to resolution for those fewer incidents that did emerge. Next, we'd like to talk about the last pillar, business agility. Stephen Orban, CIO and head of technology at Dow Jones, had this to share. Using AWS helps Dow Jones to be more agile in developing revenue-generating products. Thanks to AWS, we now build more products and spend less time running a data center. Our overall product development velocity has increased by at least 30%. The traditional IT model places constraints on innovation. If a team wants to develop a new application or service, it needs to provision resources to do so. This requires additional time and money, slows time to market, and cuts into innovation budgets. And the cost of failure is another potential roadblock. For example, if a company using on-premises infrastructure tries and fails to launch a new product, it still must support and maintain the hardware it purchased for the project. With the cloud, developers can instantly provision resources and begin writing code. Being able to try out new ideas and directions quickly helps everyone get more involved in identifying opportunities for improvement. They don't have to wait to get the budget to deploy a full infrastructure stack just to try something new, because the cloud supports a rapid, agile approach to IT that drives competitive advantage. They can avoid costs because they can shut down instances when they're no longer needed. At the same time, you can choose software solutions from the AWS Marketplace, which is our managed and curated software catalog with an e-commerce storefront. It features over 4,000 listings of software in over 30 categories, including security, networking, business intelligence, storage, database, operating systems, and business software. You can quickly acquire capabilities in certain areas by deploying this software on AWS without investing development resources in reinventing the wheel. And you can control cost as soon as you decide to discontinue by stopping installed software subscriptions right away. Traditionally, the software delivery lifecycle goes through 6 major stages, from requirement gathering and analysis all the way to maintenance. On this chart, we've also labeled the typical percentage of time spent at each step. AWS's built-in solutions, such as scalability and security, and the large number of third-party services available on AWS, as well as the availability to deliver cloud-native products, all greatly simplify the requirements design phase, reducing the resources required in the first two steps. The continuous integration and continuous delivery, or CI/CD pipelines on AWS, help you automate steps in your software delivery process, such as initiating automatic builds and deployments. The wait time can also be reduced or eliminated through automated application development and smaller deployment batches. With the options from AWS and many other third-party managed services available through AWS, you can also reduce maintenance costs and simplify operations. Now, as we mentioned earlier, the sooner we can set up KPIs, the better we can track and understand how we're progressing in different phases of the delivery lifecycle. Depending on what key milestones your teams are tracking, you might have different sets of KPIs you want to track and set targets around. We recommend setting a few KPIs around number of applications, number of features launched, time to market, time to deploy, response time, and customer retention. In our next example, we'll walk you through how we think about a specific business agility question. We recently worked with a media subscriber-based company where they had the choice of upgrading an application that affected their conversion rates on upgrade. Their consent messaging application oftentimes had forced users to wait in excess of several minutes. Now, if they were to have upgraded this on a traditional infrastructure, it would have taken 6 months. They chose instead to upgrade this application in a hybrid manner, upgrading that specific component with AWS. And they were able to do that in 1 month. So essentially, they had gained 5 months where their conversion rates were much higher because the consent messaging delays went from several minutes down to only 5 seconds when running on AWS. And as you can imagine, when your customers who have chosen to upgrade and have to wait for 5 minutes, there's a significant drop-off in those conversion rates. So, we're able to look at how many clicks were happening on a historical basis. Look at the LTV, or lifetime value, of that upgrade. Look at the 5-month period of additional time they had with that application and quantify a very specific dollar benefit. Lastly, the benchmarks that cover the last pillar here on business agility show that we have a 37.7% decrease in time to market for new features, a 39.9% decrease in time to deploy code to production, and an almost 3.5 times increase in code deployment frequency. Hopefully, you can use these statistics to ignite the way you can reimagine and transform your business to better serve your customers. We always ask customers to think about what you can do and the impact you can have to your customers to be able to deliver enhancements to them 3 times faster. We also have the customers where these benchmarking insights are compelling enough to support a cloud migration because the framework with these 4 pillars, the metrics under each, and the improvements we report are enough for them to think about what they want to measure, track, and set improvement goals for in their organization. These graphs provide a succinct summary of results. When you engage directly with us, we'll be able to create a custom peer set sliced across attributes that make sense for your migration. These are the insights from a very quantitative type of benchmarking study we performed. And a lot of these metrics and improvements have been confirmed by other research as well. Let's look back at the Live Nation case study that we saw with the earlier example for cost savings. But to make this business case complete, Live Nation also looked at the other pillars from the framework and saw benefits like a 50% reduction in traditional IT tasks, and improved availability from 3 nines to 5 nines, and over 90% business user satisfaction after moving to AWS. So, now you understand the key components in building a business case around moving to the cloud. To wrap up, it's critical to start building your business case early in your decision-making process. Invite the right stakeholders in the discussion and prepare time for multiple interactions with them. For the areas that are not as obvious to quantify values in, make sure your organizations can select the sets of KPIs you value and track them diligently. And again, in order for us all to make the right decision, we need to present the overall value, not just the TCO. Your team can get started learning with our free digital training courses. We offer over 550 courses, including the 6-hour AWS Cloud Practitioner Essentials course. We offer a variety of learning paths by solution and by role to help advance skills or prepare your teams for AWS certification. Plus, we also offer enterprise-specific resources such as case studies, ebooks, and white papers to help you accelerate and scale your modernization. Thanks again for attending, and we really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take the time to fill out our survey and let us know what you think.
Earning the AWS certification has really inspired me to study more in cloud technology and really pursue other interests in that areas as well. My favorite thing about the AWS digital training is that I got to learn a lot about cloud technology, which I've never been exposed to before. So the training really helped with my certification because it went through all the topics I need to know. Preparing for the exam really reminded me the fun and enjoyment there is when it comes to education and self-learning.
Internally, we're thinking about career pathways a lot. We are using AWS certifications as actually a stepping stone to allow people to kind of upskill on DevOps and cloud-related specialties. We have a digital resources team internally that worked very closely with me when I was building out the cloud environment for rendering. Part of their role is to watch the render farm, right? And upskilling them on cloud has been a journey that AWS has helped us with a lot. We've had people from AWS come in and talk to us about, the spot market and how all that stuff works. But once you get that down conceptually, you want to give people the opportunity to sort of grow themselves. And we've been using AWS certifications as a stepping stone so that someone in digital resources can take on an AWS certification and use that as a way to transition to another department.
The staff that returned from the systems operation training were excited, more inquisitive, asked more questions, and started to experiment more on the AWS platform. That's helping our innovation and our drive for cost optimization.
My name is Ming. I am co-CEO and Chief Platform Officer in Fastgo Vietnam. I'm in charge of technology development for the company. Fastgo is a Vietnamese startup company, member of the well-known Nextech Group. Our headquarters is in Hanoi, Vietnam, and we have offices in the major cities in Vietnam. We also established our presence in other Southeast Asia countries like Myanmar and Singapore. Southeast Asia is our primary market, and we plan to go beyond. Our system resides fully on-premise. We are facing difficulties in handling high volume of requests in real time. Adding new features to the product also takes a lot of time and effort due to monolithic architecture. Therefore, we decided to redesign a new architecture that breaks down everything into microservices. These microservices will operate independently on their own and scale on demand. AWS is chosen for it offers the most comprehensive services, easy for the team to get involved in. Most importantly, we have case study reference from the major players in the industry. Most Fastgo services now run on AWS, from the dispatching system to journey management system. Other supporting services including fare, promotion, mini-game user management are also there. We even build our own map and places system to better serve our users. Most components in our platforms are deployed in Docker containers and hosted in Amazon ECS cluster. We use Amazon Route 53 to direct the flow of all network traffic inside and outside AWS. Amazon VPC and security groups are used to separate different segments in our system, such as by country. Lambda functions are used to reduce the development time and to connect to other AWS services like Kinesis, SNS, and CloudWatch. We also use Kinesis to receive real-time data from mobile user. File host is attached, so data is also directed to Amazon S3 bucket and then processed in data analytics tools such as AWS Glue, Amazon Athena, and Amazon QuickSight. Amazon CloudWatch is very helpful in reading infrastructure metrics, storing application log, and triggering alarm firing alert. Currently, we are running 200 ECS tasks on Fargate, 45 instances on EC2 with 300 Lambda function. The platform contains 400 CloudFormation templates, and this results in faster response time and zero network disruption. We want to explore other services like DocumentDB to reduce our maintenance effort, machine learning and big data to personalize our offerings to our end users. By using AWS, we enjoy a very reliable infrastructure. FastGo platform therefore only focuses on building up application services without worrying about network disruption, hardware failure, bandwidth limitation. Our end user now enjoy a reliable connection with fast response time. Having AWS data center located in Singapore, any network disruption in any single Southeast Asia country would not affect user experience in other countries. In short, AWS brings in highly reliable infrastructure. On top of AWS, solution architects have choice to implement different design patterns and run them all together.
What makes me proud is when I see my customers succeed, when I see them come out in the newspaper, or when we see a new product launch. I feel really proud for my entire team in contributing to the business success. I lead the enterprise support team at Amazon Internet Services Private Limited. I joined Amazon around 4 years ago as a technical account manager. We are a very global team. I come from a software development background, and I first fell in love with the cloud around 2012. I personally work with my counterparts across Asia and across the world to solve large customer problems, to share best practices, to figure out what's the best way to help and advise customers. Achieving customer outcomes is definitely not a solo job. It requires a lot of team effort, and the team really gels together to make sure that what's required for the customer is actually done. We've been very successful across Amazon. A lot of customers are now asking how we can replicate the same culture. I'm actually seeing a cultural osmosis where we are able to take our culture and put parts of it or the whole of it into our customers, and that's really, really satisfying. The team spans across multiple areas of Amazon and of AWS. It's a technology consulting team, but it also works a lot with our service teams. It also works a lot with the rest of the field. If you're someone who wants to look at the big picture, look at the entirety of how AWS works, this is the best team to be in, because we get a ringside view of both sides, of how the field side works and how our internal systems work. That's the biggest allure of this particular team.